What's up everyone? This is Dariusz Kalmarczyk, co-founder of NG Poland, JS Poland, Angular Master.dev and Workshop Fest.dev. Welcome back to the JavaScript Master Podcast. Today, together with Miško Hevery, who is a CTO at Build.io, creator of Quick, Angular, AngularJS, and co-creator of Karma.js, we will talk about reactivity. Hi Miško, how are you today?
I'm doing great. How are you doing yourself?
Yeah, thank you. I'm great. Let's talk about reactivity. So how you define reactivity in context of software frameworks?
Yeah, that's a good question. Actually, last time we spoke, we kind of dived into it, and I think we can go into it a little bit deeper. And so lately I've been thinking about reactivity quite a bit. And, partly because I go in conferences and I give talks about it, but partly to kind of summarize all of the different frameworks, both for myself and for others. And I think it really comes down to three different options, right? You have reactivity based on a value. So, frameworks such as Angular, React, to some degree, Svelte. And the idea is that when you're storing the state, right, it's just stored inside of a regular value, so regular reference, either a property or a local variable. And because it's stored inside of a local variable or a property, there is no way for a framework to know when the value has changed, right? And so all of these systems that are based on value-based reactivity have some way of notifying the framework that, hey, things might have changed. And then the framework goes and tries to kind of figure out what has changed, right? And again, I think good examples of these are both Angular and React, right? In Angular, the state is stored on a property, and we don't do any magic about getters or setters, and you can have deep objects inside of properties, etc. And in React, it's the same thing, right? Like the state is stored, when you call the function, it's just stored in a regular local variable. And so there is no way for the framework to know when you kind of mutate that particular thing. Now, in both of these systems, the framework at some point says, hey, somehow the framework gets notified that hey, things could have changed. So in React, this is explicit through a set state method. And in Angular, that's kind of implicit through the change through Zone.js, right? So the Zone.js kind of observes when the code runs inside of JavaScript. And if it does, then it says, hey, I don't know if things changed or not. They might have. So we'll go and try to figure it out. And surprisingly, Svelte also belongs into this category. Svelte has a fancy compiler. So the compiler knows when you are writing into a variable, but at the end of the day, it's just a variable that exists. And so, the advantages of the kind of the variable is just kind of simple to explain. So the alternative way of doing this is through observables. And the example of that would be Angular with RxJS. Surprisingly, Svelte, again, because Svelte has basically Svelte has two different reactivity systems. One is inside of .svelte file, which is based on the value that we just kind of talked earlier. But if you want to have a reactivity across Svelte files, you have to use stores. And stores are an observable. Specifically, it is, so the resolvability is based on behavior subject. I think the key thing to understand about behavior subject, or rather the observable, is that at the end of the day, there is a .subscribe method. And because there's a subscribe, there also has to be unsubscribe. So the thing about observables is that you have explicit subscription, explicit unsubscription, which creates a problem because if you forget, you have a memory leak. And because it's a subscription, you're passing back a callback. And so there is no guarantee that the callback gets called synchronously. It might get called asynchronously. And so there are different systems. Some have synchronous delivery of value, some have asynchronous delivery of value. I think Svelte has a synchronous one. But at the end of the day, it's kind of the observables. And if you think about it, the observables are kind of the obvious way to do reactivity. It's the generic way. It's like, hey, we're going to take this value and create guards for reading and writing so that we know when you're doing the reading and writing. I guess the reading is not very important, but the writing is important. And you're gonna give us callbacks, and then we will call you to notify you when the values have changed. So it turns out that observables, though, don't have the best developer experience because of the explicit subscribe and unsubscribe. They're also kind of hard to kind of reason about. Like there's complicated courses out in the world about RxJS and all the things you can do with it, etc. So observables are very powerful. You can do all kinds of things with them, but observables fundamentally are values delivered over time, right? And because they're values delivered over time, they don't really fit the UI paradigm, which is like UI, I'm rendering and I need the current value at this point, right? And so behavior subject is kind of a compromise that the RxJS or rather the observable world created to say like, hey, I know I'm normally delivering values over time, but I'm going to also provide you like a special way of like getting the last value or the current value, so to speak. That's the second way of doing it. A third way of doing it is basically what is fundamentally observable. They're called signals, but it's observables minus a couple of things to make the DX better. And this is why people always get confused about observables and signals, is because they feel like, hey, what is this signals? Why are you excited? I can do the same thing in observable. And it's true, you can do the same thing in observables with the, as I said, behavioral subject, but the DX is not the same, right? And that kind of makes the difference. So signals, you can think of them as a much simplified observables. Specifically, they have a synchronous delivery of values. And actually, they don't really have delivery of values. They have instead a mechanism to cause re-rendering. So the thing that's different about signals is there is no explicit subscribe or unsubscribe mechanism, right? Instead, it's implicit. By reading a value when you execute the rendering pipeline, when you're rendering, you are reading different values of the state. And the act of reading is the thing that internally creates a bookkeeping information and says, you are interested in this value, which means that if the value changes, I have to re-render you, right? And so it's not a .subscribe that somebody has to call. It's more like internal thing that the framework does, kind of a bookkeeping for you. It's not even clear that the framework internally has to do a callback. And so the kind of the point with signals is there is no subscribe or unsubscribe, right? And it also means that signals are tightly coupled to the rendering pipeline. Now, yes, you can, in theory, create signals that are independent, but really to get a really good DX, you really want the rendering pipeline and the signals to know about each other and just create a really nice way of doing it. And so you can think of signals as a simplified observables that are both synchronous all the time, and they don't have any subscribe and unsubscribe. And essentially, they only have behavior subject and nothing else. Okay, so let's go back. There it is. Values, there is observables, and there's signals. And I don't think there is any other way to do reactivity. And so if you think about it, all the existing frameworks really fall into different categories of it. So kind of let's go over it again, right? So for value, right, we have Angular, you have React. You also have Svelte. Because if you think about what Svelte is doing, Svelte has a really fancy compiler internally, but at the end of the day, Svelte stores everything as just values. And whenever something changes, you kind of mark the particular tree dirty. And then what you have to do is you have to re-render, right? And so the interesting thing about the value-based systems is they are all in some form essentially dirty checking. I know dirty checking is a bit of a dirty word and people get kind of upset when you call it, but if you really think about it, that's really what's happening, right? So the Angular does dirty checking on the expressions. VDOM systems like React, they re-execute the component, which regenerates the VDOM, and then they dirty check the VDOM, meaning compare it to the previous version of the VDOM, right? So it's the same exact thing. And Svelte has some really clever compiler hacks that they, produce, compiler generation, right? And so Svelte is by far the most efficient out of all the systems. But at the end of the day, like it's a dirty checking system. And so dirty checking systems really have this peculiar property that it's really difficult to fall off of the reactivity train. Meaning, you can do just about anything in the value-based systems and it will work, meaning that eventually you will get an update to the UI, right? And that's a really nice property because they are super easy to explain to people. Like, oh, we just change this property and then the UI updates. And there aren't many rules about like, you have to follow or therefore you have to explain to the person. It's just like, do whatever you want and it will kind of work, right? And that's a really nice property of value-based systems. And I think this is the reason why they're super popular. Observables are, let's see, what's the example of an observable? So let's see. So that's Angular with RxJS is an example of an observable system. And again, I'm going to say Svelte here because Svelte has this peculiar property that inside of a Svelte file, it has the value-based system with dirty checking, et cetera, which is super efficient and super clever about how it does. But nevertheless, that's what's happening at the end of the day. But across Svelte files, there has to be some other reactivity that's not based on a compiler, because the compiler is only can work on a Svelte file. So if you want to have a reactivity outside of a Svelte file, you need to have another mechanism. And so Svelte has what's called stores. And if you look at it, store has a subscribe method and therefore unsubscribe method, and it will synchronously call your value, and it's a behavior subject. And so, it checks all the boxes to make it really a observable system. So in Svelte, you kind of use both of these technologies, depending on whether you're inside of the Svelte file or you want to go talk across the Svelte file. And, I think observables are really performant, but they just don't have the nice DX. And in the case of a Svelte, it's kind of an interesting thing because you have to have two different syntheses, two different mental models, et cetera. So I think it just complicates things for you. Okay, so the last bit is signals. And example of signals are Vue with its ref proxies. So as that Vue is definitely a signal-based system. And they don't call it signal, they call it refs. You can have React with MobX. That's essentially a signal-based system. You can have obviously Quick and obviously the king of the hill, Solid, right? And so those are all the frameworks, and it's interesting that they all fall into one of these categories. And so the nice thing about signals, though, is that signals can, at the end of the day, when the value changes and the framework has to re-render, the framework needs to basically make a choice, and that is, what exactly am I re-rendering, right? And the most obvious thing, and what just about everybody does, is they say, I'm going to re-render the component. So for most frameworks, the component is the minimal unit of work, so to speak, right? So that if anything changes, the bare minimum of execution is the component. And that's pretty much the case for everybody, except for Solid and Quick. So Solid and Quick basically have a second way of rendering, and especially Solid, where it only has the second way. And in Solid, the unit of work is not a component, but the actual DOM operation. So it's a lot more fine-grained, right? So in Solid world, when a value changes, the unit of work isn't rerun the component, but it is just update the DOM. And that's what makes Solid so efficient. Quick is kind of a straddler here. So for the most part, Quick acts like Solid, that the unit of work is updating just the DOM element. But under certain conditions, Quick is like, I actually don't know how to do this directly in a DOM operation. And so in certain conditions, it reverts back to rerunning the component. And the thing that you want, right, in terms of reactivity, is you want to have as small of this island of work as possible, right? Because the smaller the island, the less code to execute. The less code to execute, the faster you are, right? It's kind of interesting. Sometimes people will like argue which framework is faster. And the thing that is important to understand at the end of the day is that it comes down to the amount of code that has to execute, right? And so frameworks like Angular and React that have to go to the root component and then re-render everything below it. And when I say re-render, I don't mean like DOM-based re-rendering. I mean rerun the components to figure out if there's anything to do on a DOM operation. Like all frameworks are intelligent in a sense that they don't eagerly just change things in a DOM, right? They all do the correct thing and only talk to the DOM when necessary. But from the framework's point of view, when we talk about re-rendering, we mean like rerunning the component tree, right? And so on one side, you have these frameworks that kind of rerun the component trees all the time. And on the other extreme, you basically have a framework like Solid that says like the component tree just doesn't matter. It's an artifact of kind of setting things up. And then a Quick is kind of a close cousin to it, which basically says most of the times components don't matter and I will just do the right thing. Sometimes though, I will have to re-render a particular component, but Quick won't have once I render a component, I will automatically render the child components, right? Which is the kind of the default behavior for Angular and React. Like once the parent component renders, the children kind of go with it. And then they provide some escape hatches. So that's kind of the other kind of thing to kind of understand is if you have value-based systems like Angular, React, you usually have some kind of a escape hatch in the form of optimizations, right? So as you build your application, it's super easy to get started because the mental model is really nice and you kind of work. And at some point the application gets big and the performance gets troublesome. And so now kind of the experts join the team and they will tell you like how to optimize the app. And what optimizing the app really means is don't execute certain branches of the tree. So you execute only some subset of these branches, right? And so the optimization really comes down like to have some clever checks where you can kind of hint to the system like, I know nothing has changed in the subtree, don't go there, right? And so you kind of have to do this with value-based systems. Now, the interesting thing is that if you have a signal-based system like Quick or Solid or Vue, you don't have to do that. It depends on how the framework is designed. Interestingly, Vue is signal-based, but it will still cascade to the children. So if the root component changes, depending on how things get passed, it might also cause the child components to re-render, which then cause the child component of those to render, and so on and so forth. There's no out of the box. There's performance hacks you can do. Out of the box, the system kind of has this mental model that the components is the thing that has to re-render. And so what I find interesting is that value-based systems, it's super easy to get started. You just kind of jump in and start coding and everything works. And the price for the super easy way of getting started you pay for is that if your application gets big, you have to do optimizations. And the thing that I find interesting about these optimizations is that when you start doing optimizations, it is no longer this magical world of like things just work, because it's very easy to optimize a branch and then have the incorrectly and then have the particular branch not re-render. So now you kind of fallen off the reactivity graph, right? So these models are super easy to get started, but the price you pay for it is that you have to manually go and optimize. And when you start optimizing, it is relatively easy to fall off the reactivity graph. So if you compare that with signal-based systems definitely have a more set of rules like you have to follow. So in terms of like learning curve, it might have a little higher learning curve to get started. And also, there's ways to fall off the reactivity cliff. If you don't follow some of these rules, then the application stops updating and then you kind of fell off the reactivity magic cliff. And so a lot of people will argue like, hey, but the value-based system is much nicer because like you don't fall off as easily. So it's a better mental model. And it's true. It is a better mental model from that point of view. But now notice what happens when the application gets slow. when the application gets slow and you start doing the optimization, you're essentially in the same exact boat as signals. Whereas if you don't follow the right rules, then you've fallen off a cliff, right? Whereas in a signal-based system, there is no optimization. Like, like if you build an application with signals, that's it. That's what the application is, and there is no optimization step. So by paying the learning cost early, you save yourself the need to do optimizations. Okay, but there's also one more thing, which is how the applications fail, and I think this is important, and this is actually what kind of sells me on the signal side. So with value-based systems, the applications fail slowly, meaning as the application gets bigger, it gets slower and slower and slower. And there isn't really a line in the sand where the application breaks. It just becomes, at some point, too slow to use, right? And this is especially a problem for us because we developers have these fancy, fast machines. We're on localhost. And so our threshold for when it becomes slow is much higher, or rather it's less visible, right? Whereas for a user that is on slow network, has a mobile device, this threshold is reached much, much sooner. And once you reach this threshold, the problem is there isn't an easy way to say, oh, the problem is right here. If I just fix this thing right here, things go back to normal. No. Once you become slow, it is like this long list of tiny little improvements that you can do to improve the performance of the application. And oh, by the way, as you start doing this tiny set of improvements, you are now running the risk of falling off of the reactivity cliff, right? You may incorrectly optimize something for performance, and the result is that the branches do not update as they should be. So essentially, you have the same exact problem as the signals have over here. Now, in signals case, when you fall off the cliff, the result of that is very obvious. Like your application fails immediately and now. And when that happens, it is really easy to figure out what went wrong because you can pinpoint to a specific mistake you have done in your application. And if you fix this mistake, then, reactivity is restored. So in my point of view, right, what world do you want to be in? Do you want to be in a world which slowly creeps on you and fails in this weird thing? And when it fails, it is really hard to figure out what to fix. Or do you want to be in the fail fast world where the moment I make a mistake, I'm immediately told, this is the mistake, you need to go fix this, and things become back to normal. And so it depends what you value, right? If you value getting started quickly, then the value-based systems look a lot more appealing. But if you're more experienced and you've built many large systems, then maybe you value the safety of not having to go, discover one day that the application is slow and then struggling through many months of optimization improvements. And you just value being able to deliver continuously. And so there is a trade-off here where with signal-based systems, you have to pay a little bit higher upfront. And I personally think that this little bit higher is a very small price to pay, but it is a price to pay because it comes down in the form of few more rules that you have to understand. Not everything goes. There are rules you have to follow. But then again, if you think about it, if you are a React developer, there are rules you have to follow with the use methods, right? Nobody's complaining about those, but there are all kinds of rules. You have to make sure you call them in the same order. You cannot have a loop. You cannot have an if statement. You cannot have a conditional, right? These are the rules that you as a developer of React have to follow. And I think the reason why nobody's screaming about these rules is because there's a great amount of value that you get out of them. But also, if you don't follow the rules, the error is immediate. You don't find about this error months down the line. Immediately, the app is broken, it doesn't work, there's an error message, fix it, right? And so as a result, even though these rules are extra rules that people have to follow, the benefit is great, and people kind of happily do so, and nobody really complains about them because there's immediate kind of feedback on it. And so I think signals are in the same kind of categories. And so people like to make these videos where it shows look how nice it is in React and Angular where whatever I do, reactivity just works. And look got all these foot guns in signal-based systems where like you can fall off the reactivity. If you do this, all of a sudden it doesn't work. Why not, right? True. Yes, that is fundamentally the trade-off between the systems. Anyways, to kind of review, right? I think there's fundamentally just three ways to do reactivity, right? You either do value-based systems that are fundamentally a dirty checking systems at the end of the day, right? Where somehow you have to tell the framework, now would be a good time for you to go and recheck all these values and see if a rendering has to happen. That's kind of one extreme. The other extreme is essentially all signal-based systems where there's extra set of rules which you have to follow. And if you follow them, then you get kind of reactivity. And then there's this observables, which is kind of in the middle. You kind of get all the benefits of signals with observables, but they do have this more complicated DX where you have to do subscriptions. And as a result, you can miss subscriptions. And because you can miss subscriptions, you run the risk of memory leaks. And because subscriptions are things that are explicit and you have to kind of unsubscribe, they tend to be a lot more static, meaning that once you set up a particular reactivity graph, you tend not to change it because, dynamically changing it all the time would kind of risk that you kind of mess up the unsubscriptions. And so it's a different kind of a philosophy than signals. The nice thing about signals is that because it's implicit, like the subscription happens automatically, there is no cost to changing the reactivity graph as the application runs. And people kind of do that without even kind of realizing because it's just much more natural. But anyways, that's kind of the three boxes, and I think everybody really falls into one of these three boxes.
Can you elaborate the trade-off between the cross-grain and fine-grain reactivity?
Yeah, so value-based systems are really coarse-grain, right? Meaning that when the framework gets notified that there's a change, at the very minimum, the framework has to re-execute the component. That's the minimum unit of update. And again, when I say re-render, I don't mean in a DOM, right? That's framework authors use the word render to meaning rerun the reactivity chain, not necessarily rendering to the DOM. As I said, all frameworks do the smart and an intelligent thing and only talk to DOM when necessary. So when a change happens, you have to re-render the graph. And then the minimum unit of work for just about all frameworks, with the exceptions I think of Quick and Solid, is a component. Now, some frameworks have the cascading effect, which is that if you start re-rendering a particular component, you automatically start re-rendering its children unless you do extra work to kind of optimize. And different frameworks have, some of it, they are, Angular kind of being on one extreme where like it just blindly reruns all the children. And then, Svelte and Vue being not the other extreme, but like kind of more in the middle, because they're like, oh, you didn't do a data binding, so I will not go there. React is somewhere in the middle in there as well. But fundamentally, some of these pruning of the trees can be done semi-automatically by some of these frameworks. But they always provide additional escape hatches where you as a developer can hint to the framework to prune the tree even more aggressively, right? And so that's one extreme. The other extreme are frameworks that say, no, the unit of work is not, or the unit of re-rendering is not a component, but the DOM element, right? So if you look at an example of a counter, and if I increment the counter, most frameworks will rerun the counter component. That's what I mean by re-render, right? They rerun the counter component. Except for Solid and Quick, where they're like, well, the count value is attached to a particular DOM element. And as a result, I only need to go and update the DOM element. I don't need to rerun the counter. So with frameworks like Solid and Quick, you are significantly decreasing the number of times the components execute. Now, Vue is also solid signal-based, right? Except Vue has a particular thing which they don't optimize. And so imagine you have a counter and the state changes, and then counter passes the value to a child, which is, let's call it a wrapper, doesn't do anything useful. And then the wrapper then passes the value to a display component, which actually renders the component, right? What happens in the Vue is that if the value changes, then you're automatically rerunning the wrapper component, even though the wrapper component doesn't do anything, just passes the value onto the display, right? And then you, of course, are rendering the display. So you're rendering the counter, the wrapper, and the display. But frameworks like Quick and Solid, they follow the signal path. And so they know that like, oh, I know that this signal is being passed to the wrapper and the wrapper passes it to the display, but I see that the signal is attached to this DOM element. So when you update the signal value, there is no need to run the components. You literally just go to the DOM and update the DOM, right? And so you skip this. And so one way to kind of look at frameworks is, what do they do when you're passing a value through a otherwise inert component? You know, there's a lot of components that we create for the purposes of kind of layout, but all they do is they pass values to their children. They don't themselves do anything, right? And so the question then becomes is, do they rerun? And in vast majority of cases, the answer is yes, they rerun. And so really you should really look at it like, what is the minimal amount of work that has to happen? And for the most frameworks, it's the component. And then further question then becomes like, well, what happens if these values get passed to children? Are frameworks good at pruning the execution of children? And again, you can kind of put them on a scale, and like some are better at it than others.
Can you give us some examples?
It really comes down to what is the unit of work, component versus the DOM element, and how good the frameworks are about pruning the branches where the data isn't going through, and how good are the frameworks at pruning the intermediary components that don't do anything, just pass the value to their children, right? And a better a framework is at pruning all these things, the more fine-grained it becomes. And the ultimate in fine-grained reactivity is basically that the components essentially disappear and it's all just direct DOM access, right? And that's essentially what Solid is in all cases. And it is what Quick is in vast majority of cases.
Then why not use Solid all the time?
Quick is very close to Solid, where in vast majority of cases, we will behave in the same way as Solid. But in some cases, we will go back and re-render the component. And so the cases where we go back to re-render component really have to do the difference between when the component changes structurally. So vast number of components really don't have any if branches inside of them, or if they have the if branches, they're kind of stable, right? And so they always render the same DOM structure, just the values are different, you know, the attributes or the text results or things of that sort, right? So to us, we differentiate, is the rendering operation or with the change in state, will it result in changing just some values, some attribute and text nodes, or will it actually involve changing the structure of the DOM? If it falls back into changing the structure of the DOM, Quick reverts back to rerunning the component. And the advantage of doing that is that if you do not rerun the component, then you have a particular problem, and that is, how do you do meta programming? Let me explain what I mean by that. What if your component says, oh, I have a child component, but the child component isn't known at the time of compilation? What if the child component is a value that is a result of like some computation, some data set, some operation, right? So you can imagine a case where you have a list of emails, and so you have a for loop between your emails, and you would think that the individual items would be an email, right? But maybe what you want to do is email is the default, but sometimes you recognize that this email is about a calendar. And so you really want to render a calendar widget in this particular place, not a regular email widget. or you recognize that this particular email is about you buying a tickets to a plane, right? A travel thing. And so you want to render a different UI that is really telling you that this is a ticket that is going from this location to that location, and maybe there's a button to add it to a calendar or a button to do a check-in. And so you can kind of do this like that, right? And so at the time of rendering, you do not know, or rather at the time of compilation, you do not know what is the child component. And so this is actually something that is super easy to do in React, because you define a variable called child with a capital C, and then equals, and then you run some function that computes which child you should have. And then when you want to use the child, you simply put it in a JSX with a capital C, right? And the JSX will look at it and be like, oh, that's a capital C, and therefore I know this is a dynamically bound component. System like Solid, they can't do this. Because they don't rerun the JSX, they don't know, there's no way for them to know if a particular component is dynamic or not. And so as a developer, you have to essentially explicitly create a special component in Svelte that says, oh, this thing right here is a dynamic. And because it's dynamic, instead of passing the component to you directly, I'm going to pass the component to you as a prop. And then basically what the dynamic component does is this does the switcheroo. Now, turns out Angular also has this problem, right? Also, I believe the same problem exists in Svelte and in Vue, because all of these frameworks fundamentally have templates, and they all assume that the templates are fixed, that they don't change. And so when you want to do a dynamic trick like I just described, Angular has something called ng-outlet. I'm not an expert on Svelte and Vue, but I believe they also have kind of special things. And of course, Solid also has a special thing for kind of doing dynamic component codes right here. It can be, you can make a really good argument that React out of the bunch has the nicest DX, because you just put it in the JSX and the right thing kind of happened. There is no special thing. And so in this particular case, this is where Quick kind of goes back and reverts into the way essentially React behaves, where we re-render the whole component. But unlike React, that will automatically render its children, in Quick, the re-rendering is bound to just that component and nothing else. By doing this trade-off, I think you can get the DX of kind of the React in this particular case, but you get the performance of Solid in most cases, and in few rare cases, you are very close second because you re-render the whole component, but you're smart enough not to go into, the child branches, etc. So you're extremely aggressive about going to your children so that you kind of focus on the component itself. So that's an interesting kind of a trade-off that we chose to do. Maybe in the future we'll solve it in a different way, but as of right now, that's kind of the way it works. And I think it's kind of interesting to look at it, right? That all of these kind of choices are about DX trade-off. Like, what is the thing that you want to present to the developer?
Thank you so much to our special guest for joining us today on the JavaScript Master Podcast. Your insight into the world of reactivity in modern frameworks have been truly invaluable. We greatly appreciate your time and expertise in sharing this knowledge with our community. For all our dedicated listeners out there, stay tuned for more exciting episodes. We are continue to explore the ever-evolving landscape of JavaScript and front-end development. Remember to subscribe, and if you found today's discussion insightful, please share it with your fellow developers. Until next time, keep coding and keep exploring the fascinating world of web technologies. Thank you for being a part of the JavaScript Master community.